we were in middle of talking about the type of contemplations that lead one to a Emunah and HaKadosh Baruch Hu, and it's important to retain that as the superstructure. The one we had spoken about last time was existence on a basic level, matter, and the basic laws of science that are immutable and are locked into every bit of creation. That is the first contemplation. The second one is going to be something that will lead us into another topic, but important to keep in mind the basic structure and not to wander off on a lot of side points. The second topic is going to be the complexity of the world above the basic level. In other words, where do rocks come from, and water, and the laws of gravity and the laws of energy and physics and so on was the first one, the Yesh Me'ayin. And now when we take a look at all the complex things in the world, specifically the things that are living, plants, animals, human beings, as we study that and as we gain more and more knowledge of the extraordinary complexity of a person, we are overwhelmed with the sense of somebody having designed it and somebody having made it. Nobody would think that a simple watch came into being by itself. It's certainly not something as a human being, which is really infinitely more complex. That has been one of the standard hisbonenus psukim in Chazal. Avraham Avinu looking around the world and saying there has to be somebody behind it. Common sense and throughout religious philosophy, this has been really the mainstay, that a person looking around and seeing the extraordinary complexity of man is the most closest at home and most complex, cannot but say that there has to be someone that created it. It's a very, very powerful point. It's probably the most powerful point. It's something that we can brush aside by just saying it in one sentence. Well, man is very complex. But if a person were to study biology and look at every single bit and piece and how they have to tick and how they are coordinated and so on, we would have to come to that conclusion. That line of hisbonenus and thinking was universal until a few hundred years ago, when people started, even though Darwin was the famous one, but like all great ideas, there was already some precursors where he started thinking maybe there's an alternate explanation. And if the alternate explanation works, then we no longer have this compelling argument for Borei Olam. That was the general theory and idea behind evolution. Now, as we said before last year, the theory of evolution and the facts that have come up with the theory pose two issues. One is it seeks to stop this hisbonenus of saying there must be a creator. If we find a reasonable alternate explanation, then we no longer have this compelling argument about HaKadosh Baruch Hu. There was a second issue that even if we're to accept HaKadosh Baruch Hu, but a lot of what the Torah seems to say seems to be contradicted by what we find around us in reality, and that became that became a testing ground for religion. We will not be addressing that second issue. That second issue has its own framework. We need to address it at a later point when we speak about Torah and the emes of Torah and so on. The first point is the one we're going to be trying to address in these in this year, maybe the next year. If we find a viable explanation, then we are going to have a credible alternative. We're talking about three things that overwhelm us in their complexity. One is living organisms. Inanimate organisms are complex only, they're not really complex. A rock is piled on dirt and earth and so on. The word complex doesn't really apply to it. It's just a mixture of a lot of stuff. But from non-living to living, how is something living? That was one area. The second area is from the simplest form of what we would call living, which we need to explain in a minute. How do we get to very complex organisms? And the third issue is, how do we get man, if we're to define man in ways that are unique, so that there's no compatibility between anything else and man. So in our hisbonus towards Emunah, we have three phases. Where does life come from? How does something inanimate become animate? How does something that will, if whatever we'll define as the minimal stage of animate, develop into such incredible complexity? And how do you get man, which will need to define how is he different? So, Darwin was the one that's famous for it, and we'll go, and I guess I'll try to give an overview to the best of my understanding of the different facts that lead one to believe that there's an alternative explanation. If we look around, if we start digging around, we start finding remnants of animals that do no longer exist. Animals, it's sort of bacteria or plant lives that are assumed to not exist anymore. How old are they? When were they? So there are two basic ways of dating it. One is by radioactive dating, carbon-14, which means as follows. Most living things ingest a certain amount of a tiny drop of radioactive material. As the person dies, and as is the nature of all radioactive material, it begins to wind down. It has half-life, and it begins to lose its radioactivity. And over a given amount of time, using a quite simple formula, the radioactive material will be converted to non-radioactive material. This is dating that works well for a huge amount of time. It doesn't work well for 1,000 years this way, 1,000 years that way, but it does work well. So as we begin to date different things, we find formerly living entities. We begin to notice a type of a big gap in time between the things that have died recently and the things that we think are the earliest. And if we're to use this radioactive dating, it would come out to hundreds of millions of years difference. So the first thing is, we now have things that lived hundreds of millions of years ago, as per the dating. That is step one. We also have a second way of dating it, and that is the world. If we start digging around us, we find that the earth is layers and layers, different places, different layers, and so on. A lot of those layers are akin to the type of layers that happen when rivers dry up, when rivers deposit earth. We see that all the time. That's a process that we still see. We can see water depositing earth. It then recedes, it dries up, and it forms a distinct layer. It's a distinct material, a distinct height, and so on. If we dig down, we can look at different layers and get a sense, possibly, of how long ago those layers were. So we will find that in certain layers that we assumed, if there are 6 layers of material and each material takes X amount of time to happen, then it must have been a long time ago. We also find all sorts of weird sea life on top of mountains and different places where obviously there have been huge geological changes. There's no way an oyster could have happened to climb onto the Alps unless they had been covered by water once upon a time, and life was, all sorts of remnants, life was deposited all around. So we have the radioactive dating, we have the different layers of the earth, and we can therefore give some sort of time frame for it. Now, we notice that the earlier life forms seem to be a lot more primitive than the life forms we have. They don't exist anymore, and they vaguely resemble things that we have. So we can make a reasonable assumption that as time went on, life went from the more simple to the more complex. Now, the issue is, but how did that happen? We didn't have any mechanism that we can measure it with, so how in the world could that have happened? So Darwin supplied the missing piece of theory, and he said as follows. He observed, this was even before they really had a good sense of genes and how they worked, that there is a natural process where animals that are more suited for survival will survive. If you have 10 dogs, the strongest dog, the quickest dog, the dog that needs the least amount of food, the dog that can live on the most types of food, whatever it is, any trait that will allow it to survive will keep emphasizing a particular type of strain. So a stronger lion the lions will keep getting stronger because the weaker lions died, were killed out, couldn't find enough prey, were attacked by the stronger lions, etc. And therefore, over time, character traits that made things more capable of survival survived. So now we have an explanation how it happened. We have the character traits that are better. So every species keeps changing, and therefore, if, for instance, having a sense of hearing gives you a big advantage, so whichever type had something akin to a sense of hearing, that would survive, etc., etc., etc. So that was a general theory. He pointed out different things in an island that he studied, things which seemed to indicate that you see that the same species, the same type of bird, depending on where it was located, or same type of snake, same type of bird, would have characteristics that makes it suitable for the type of coloration, the type of subtle changes. So here we have observed in front of us something which brings out it will naturally favor the survival of the things with more favorable traits, and as millions of years goes by, you keep getting those animals that have better traits, different traits, and so on, will keep moving forward. That was his general theory. As we became aware of genes and the mechanism of genetic heredity, we added to this picture, and we said there's another way how this happens. First of all, genes, every person contains many genes, some recessive, some dominant, and everyone has the capability of having children of different types, and therefore the child with the characteristics most suited for survival will survive. Secondly, there are random mutations where genes are broken and they produce something that was not expected, something that should not have been there. And therefore you'll get occasionally something with an unusual trait, and that's a big, instead of, let's say for instance, having a dog that has different colors, well, you might get a dog that has no color or something like that, and if that would be uniquely suited, that broken gene will become kind of the permanent gene. So this sort of fleshed out the theory. The proofs, in other words, the arguments that this is that this is correct, that it was a slow process of evolution, meaning it evolved from one thing instead of somebody sitting down and making it all, was buttressed by 2 or 3 more points. One is all animals resemble each other remarkably. In other words, every animal contains almost the exact same DNA. There's very little difference. The difference between us and a mouse on the DNA level, on the genetic level, is a pittance compared to reality. And the argument goes, if you had a creator creating everything, he would have made humans out of humanity and mouse out of mouseness. And if he was a chatchila setting up to do everything, you would create everything in its way. The fact that everything is almost exactly the same material with small variations, doesn't that show it simply is the old material with variations? That was one train of thought. Second train of thought was, you find resemblance in organs that are imperfections in the second stage. For instance, we have appendixes. Appendixes are not useful organs, and they help young surgeons make a parnasa, so it is kind of useful, but other than that, the only reason why it makes sense is because animals like cows have stomachs where they store material, and that's where the fermentation takes place, etc. So this makes most sense to say we came from the cow, and this was simply an incomplete development. Maybe someday we'll be born without appendixes because the human race will favor small appendixes, no appendixes, etc. There's also a bone at the end of our spine, which during the embryo stage resembles very much the tailbone of animals, and then it shrinks down to nothing. Doesn't seem to have any terrible useful use for man. So the best assumption is that it was probably as a species without a tail arose, there was nothing that particularly favored people without those bones, and the mela, that's there. So the vestiges of things that are not particularly, have no use, and with a plausible explanation of it coming from something that was, is the most reasonable explanation for it. So the organic construction of a person, and of higher forms of animals, where there are things there that don't make any sense in what is easily explained by it came from someplace. Also, the genetic code is almost exactly the same for is exactly the same for every being, which makes sense that we all came from one point, just developed into a more complex variation of it. That's the most reasonable explanation. There's another train of thought that seems to support it, which I think, to the best of my understanding, has been given much less credit. An embryo seems to go through stages of looking like earlier animals till it becomes a human being. It's very hard. I don't know. It's something I don't know. It's a question. Looking at the eye, I mean, anything small looks like a tadpole. It doesn't. It's very hard to know how accurate an observation is and how subjective an observation. It's not a particularly objective fact. It's something that is very subjective. It's just like you can look at the stars and you can see the Great Dipper and the Small Dipper. You could say just a bunch of stars in somebody's projected imagination. It's a much less, the embryonic development is much less of a support. But the other ones were all a support that the assumption was as follows. If there was a creator, then he would have made each thing individual as it is. He would have started out and made man in the way that's best suited for man, mouse the best suited for mouse, flowers the best suited for flowers, and instead what we get is a mishmash of stuff. We also, if we structure the living beings, we get a continuum from the simple to the most complex. If we look at the different fossils we find, they also seem to fit in different holes and nooks and crannies between different species, which kind of leads you to feel that it was a continuous process from the simple to the most complex. That basically is the theory and the understanding of evolution, the way modern science understands it. It's accepted it's universally accepted almost as a fact, and therefore it minimally, it doesn't, in itself, it cannot deny there's a God, but it takes away the argument that there needs to be a God. If I can explain If I can walk into a room and I see a cake baking, and I say somebody must have made the cake, if I can show you that that does not have to be like that, for instance, let's take a very simple muscle. If a fire starts in a shed and no one was there to light a match, I would, and I say automatically this arson, somebody must have lit a match to it. But if I can show you that rags and paints and things like that can have spontaneous combustion, which they can heat up enough on their own, so I no longer need to be convinced it's arson. I can look at spontaneous combustion. So the theory of evolution, provides a supposedly credible alternative to the existence of a creator of intelligent design. It tests, in other words, it questions the validity of the Torah description, the way it's described, and that's a very second parasha, so we don't have to deal with. And also, the scientists point out that if you look at every being, we could have designed a better being. That people stand erect. Standing erect is a horrendous way of supporting the body. It's true that if you need to eat bananas off a tree, standing erect is a great way to do it. But other than that, it's a tremendous feat to stand on your feet, pardon the pun. You have to balance yourself. A behemoth has a much easier time. It stands on 4 solid feet. It produces tremendous pressures and pains on the foot, and that's why podiatrists have parnasa, because you have it. It's not the best way to design it. There are many parts of the body that a modern engineer could tweak and do better. So perfect, if the one who designed us is supposed to be perfect, the design is far from perfect, then we can show different things that we could have done better. That is more or less, to the best of my understanding, the overview of this evolution. Now, so let's step back and ask ourselves, how do we relate to it? Now, this theory tries to explain the rise of life, the middle phase of this exponency. How can we have something as complex as a human being? You start off with a simple cell, your little E. coli bacteria, the friendly little E. coli bacteria, that little nothingness, and we can, with time, the bacteria that was able to work with another bacteria together did better, and the bacteria that had a little stomach did even better, and so on and so forth. And give it enough time, then we can get to something as complex as a person. That's what it seems to, yes?
Just for clarification, evolution is not dealing with how that first cell of quote-unquote life would have come into being, just like physics is not dealing with how the laws of physics
right
exist.
Now, the theory of evolution did not work on that. However, and there is a discipline called abiogenesis, which needed to do that, which, modern science again is looking to see if there's a credible alternative to a God figure, and there are theories. The theories of that work as follows. First, let's go back. So this theory explains the middle piece, or seeks to explain the middle piece. Man being different than animal is not taken as a given. Man is simply a sophisticated version of a primate. We cannot draw a line and say man is uniquely different, except that we're men, and so we don't eat our own kind. But morally, man is just a more developed way of a primate. The way a primate might be a more developed version of a mammal. The way a mammal is a more developed version of invertebrates, etc. So evolution needs not deal with the third phase, because man is not yet proven to be unique in a way that's not just a modification of a previous model. And the first point, how did we get from water and sand to living things, it's not dealt with standard evolution, but there's a great discipline of science that obviously needs to fill in that part. The explanation to that rests really in something that is a question that we can't even answer, and that is, what is life? Now, In the big picture, we can define what life is. The problem is always in the details. Rocks sit and do nothing, and they're acted upon. Anything that happens in the rock needs to find explanation from outside the rock. The water wears it down, the sun dries it out, the person kicked it, and so on. Life is something which is an active force. An active is not, again, the wind or the water is active. The wind is a product of heat and cold and etc. The water is a product of something, of gravity, the water flowing, etc. A living being will be active. It will look for food, take in food, throw out waste, move to some degree. Even if it's a plant, it's going to grow outwards, it's going to bend towards the sun. It will create its self-preservation. It's a dynamic process as opposed to a passive process. So how do we get to that? That's a very challenging riddle. And the general explanation I guess it's not even an explanation at this point, it's kind of the way in which we get to it is by trying to come up with the following formula. Protein molecules have the trait that they replicate themselves. In other words, it is assumed, let's put it this way, that certain molecules, just because of the nature of the molecule, will, anytime it comes in contact with other material, will replicate itself. And therefore, if we can get that first molecule to come about through an accident, if you take water and nitrogen and carbon and different goodies and you put a lot of pressure and so on and so forth, you give it the same random type of forces. At some point you will produce a protein molecule. Protein molecule has it's not the ability to, but rather it has the trait of, just like iron and water rust, protein replicates itself. That's just the way it is. So we have our first process of things happening, and that's where we have our first key towards it. So the trick is to try on laboratory conditions to get a lot of different materials to kind of bombard in all sorts of cosmic energies and electric energy, anything possible. The first thing you always look for at least a possibility and then see if it would fit the scheme. And once I have a molecule that is a protein type molecule, then we have the key to the beginning of life. That gap has been tried to answer that. That is basically, I would say, basically the points that the general description of scientific thought today in these areas. Now, let's try to think about it. And again, I'm not a scientist. I've read some. I may be wrong on some pieces. Things might change. But once again, I will be held accountable, Lashad Lavo, for the level of understanding I have. I need to think about it, I need to contemplate it, and I need to understand what has been proven, etc. I am going to be I am going to be using some books that I'll quote from, and the common denominator of these books are all of them except for one. These are three books. They're published by Oxford University Press. The reason why I chose it is simply because it's actually by random evolution. I'm on their mailing list, and whenever I have a sale, and I like something that they send, so if it's under $5 to $10, I am a customer if I like it. Oxford University Press is a very respectable press house. None of these books, except for one, and I'll tell you which one, that's not the one of Oxford University Press, are religious, trying to prove religion. They're not at all engaged in the sugya that we're engaged in. They are all dealing simply with different things in science and explaining. One is on cells, one is on molecules, one is about a general overview of science, and the big sugyas of science through the generations and what they were about. All of them, none of them are, I just happened, reading it, there were things that I was very struck by that I'd like to share. The first one is actually, it's called The Invisible, let me just see. It's called Stories of the Invisible. It is not science fiction. It's not at all about invisible people. It's a guided tour of molecules by a person called Philip Ball. And this Philip Ball is a science writer, consultant editor for Nature. He was the editor for Physical Science for over 10 years. His previous books include Designing the Molecular World, Self-Made Tapestry, H2O, Biography of Water. Holds a degree in chemistry from Oxford and doctorate in physics from Bristol. He lives in London, where he also has a theatre company. As standard as you get, and the book is simply about different molecules, and it talks about complex molecules and easier molecules. Now, this is on page 46, and now we're talking about a cell. As you remember, once we shake together a few chemicals with a lot of pressure and energy, etc., 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 we come up with a cell, which is very simple, non-dramatic, and easy to produce. And then we're on our way to make a more complex cell, etc. He's trying to explain at the level what is molecular biology, and he Haldane attributes to Engels the proposition that life is the mode of existence of proteins. So a protein is the first step that we can call living. This vitalistic statement implies that proteins are inherently alive, an idea that Haldane squashes. But he has no objection to the idea that proteins are the stuff of life. So protein is definitely the material this is basically the material of cells. Many of them are enzymes, which are absolutely necessary for life, because all of the processes that happen in a cell need to happen in a reasonable time. If it took you 1,000 years to digest the meal, you would starve to death, and that would be it. So with enzymes, where you hurry it up a few thousand times, life can actually happen. Now, if the cell is a city, enzymes are the workers. To keep the city running, raw materials are imported and converted into useful items. We bring in food and stuff. Enzymes populate the cellular factories in which this is done. One curious aspect of this manufacturing industry is that it includes factories for making enzymes, for making the workers themselves. Enzymes, too, are put together in a production line. So the cell consists of enzymes, which produce the same enzymes that they are. So to be living, you need to have the ability to produce yourself. Not all proteins are enzymes. Some serve a structural role, providing the tissues of the bodies. Some act as the cell's police force. Others carry packages to and fro in a protein shuttle service running on protein tracks. Some operate the portals to the cell. In other words, one of the most complex structures in the cell is the little skin around the cell that has to make a decision who to let in, what not to let in. It's as complex as they come. Some operate the portals of the cell, sitting the outer membrane, opening and closing in obedient response to the instructions they receive. Now, stop quoting. How many different types of proteins would you guess there are? How many different types of functions does a cell need? 5, 6, 7? There are something like 60,000 different varieties of protein molecule in human cells, each conducting a highly specialized task. So the first thing is 60,000 different things have to function. If the protein whose job is to guard the portal is away for a long weekend, the cell dies in the weekend because lo lech. And if I have one protein, you need a protein to keep out viruses, and protein to keep out bacteria, and protein to keep out heavy chemicals, and a protein to allow water in. And you're talking about 60,000 different proteins that have to work in tandem, and each one is doing something, and it's not even clear how it knows what to do. Yes, you.
It's not 60,000 different proteins in each cell. That's 60,000 proteins
in human cells.
The human cells.
Yes, but once again, it's so we have X amount of different cells. We have liver cells, kidney cells, but the number it would now. The second thing is we don't even know how they work. Listen to this. It would generally be impossible to guess what this task is by merely looking at a protein. Now, when you look at a microscope and you look at, and you molecularly analyze a protein, you're clueless what it does. They are undistinguished in appearance, mostly globular in shape, and composed primarily of carbon, hydrogen, oxygen, and a little sulfur. All the proteins that fulfill a particular task have the same shape and structure. The seeming amorphous blob is in fact exquisitely designed and assembled. So we have 60,000 different types of active things. It's not bits and pieces. You're talking about things that have a function, do things, accomplish things, and we don't even know how to do it. And science hasn't figured out because they look alike. Chemically, they're very similar, and on a big level, proteins behave the same. You cook a protein, it gels. It's like white eggs, egg whites, and fish and meat. And it's not very, very different. And yet each one has a different function, and they have to function in tandem. And then he goes through different functions. That's one point. Second point, in that same book, in the same chapter, but further along, he speaks about the mitochondria, and these are extremely complex factories inside the cell, and each one. This is something that comes from the mother rather than from both genes together. It has everything else. Everything else is it's the yotzim min haklal. Now he goes on to a second issue, and it is this is a second issue which is very difficult to understand about life, and it is probably the most difficult to understand about life. Okay, you have this incredible complexity of the proteins, but the proteins themselves don't make themselves. They are not what they are. There is a book of instructions where everything is written in code. That's called DNA, which produces all these proteins. So let's sit back a second. If the cell were a combination of different proteins, and let's say eggs and sugar and flour, let's give a mushal. Let's say eggs, sugar, and flour together make a cake. So if I see a cake baking in the oven, I say, oh, somebody made the cake. But let's say the cake itself, so I say that can't be. I say, well, the oven had to be on because somebody forgot to shut the oven. That happens quite often. And there was a pan there, and somebody was taking flour to the garbage and some of it fell in. Somebody was taking sugar and it fell in, and an egg from the top that was cooking cracked and fell in. Together you get it. So okay, that's a mikra. It's a coincidence of different elements come together, but that's not what a cell is. A cell has a code book that's the thing that produces all these proteins. Now, the code book is not another bit of material. It's written in a language, in a universal language, and so we cannot have these proteins made without the DNA. We can't have DNA without protein. Let me read you the RNA world. All living organisms, from the humblest of bacteria to the most regal of kings and queens, have their genetic material packaged in DNA and put into effect by proteins. So the DNA is the book, and it's not a lumps of protein. It's a book with a code for producing materials, and the proteins are the messengers that accomplish what's written in the book. This implies that all life has a common origin. And then he has a little note on the bottom. We simply do not know whether the DNA-protein partnership is the sine qua non of life. In other words, it's impossible to have without it. And it would be rash to suggest that life can have no other molecular basis. But none has been found. It is not so difficult to imagine that slight systematic modification of DNA could give rise to an alternative genetic system. But no organism shows such a thing. There's one code all across the board. The most primitive single-celled organism must have contained proteins and DNA very similar to those in simple bacteria. The word simple is in scare quotes. But what came before? The molecular symbiosis whereby DNA encodes proteins and proteins help DNA to function, to replicate it, is fantastically sophisticated even in bacteria. Neither proteins nor DNA could have come spontaneously in existence from fragments of organic molecules scattered throughout the seas, lagoons, and Earth. Let me give you a muscle. Their structures are just too complex to have assembled at random. It is easier to understand the 3.8 billion years of evolution of the earliest bacteria algae to the present day than to understand how in maybe just a few 100,000 years Earth changed from a barren planet to one that created life. Chemists have devised many inventive schemes and they put together all of it. They are all tentative. No theory yet prevails for the chemical origin of life. But the conceptual difficulties in progressing from rock, gas, and water to prototypes of biomolecules are still smaller than those of turning those building blocks into functioning cells full of proteins, DNA. It is a chicken and egg problem. On their own, both proteins and DNA are useless. Now, let's give an example. You walked into the kitchen and you found a cake baking. And you said, oh, somebody's been baking cake in the kitchen. And someone says, no, the oven was open, there was a pan there. Happens. That's not infrequent. The flour fell in, the sugar fell in, the this fell, that fell in, and so on. It stretches the imagination, but it's still within the realm of possible. Now let's say you open up a cookbook, and you find in the cookbook instructions as to how to make that particular cake. And then you find 5 cakes, all of them following the cookbook, and all of them in that, and each one a different cake. So now it could be a cookbook could also have by itself. That there was ink and stuff. Let's go all the way out. Put the cookbook together with the cake, and now we have an example where the cookbook without the cake doesn't exist, and the cake without the cookbook doesn't exist. We have a written instruction. A person finds a sandcastle by the ocean, and the sandcastle is a nice sandcastle, and somebody must have made it. And someone says, no, the water washed it away. Animals came and jumped in. It's plausible. A sandcastle is not complex, it's just a mound of it. But let's say you find a drawing of a sandcastle next to it. So if you can prove the drawing came afterwards, that makes sense. But if the drawing came beforehand, that doesn't, and then let's say you find 10 of these sandcastles, different shades of things, each one has a drawing by it. And once again, let's say the drawing is earlier. Every single living being is a book and a fulfillment of the book. I don't want to get dramatic and say it's a Dvar Hashem and a Kiyum Dvar Hashem. Let's leave religion out. We're still in the middle of evolution. We haven't gotten anywhere near religion. But it's stupendous. It's a code that tells you, the code itself is not a conglomeration of proteins. A living being is a conglomeration of chance chemicals. This is a code written out, spelled out, how to make life. How did that get inscribed? How did we get a book? It's not material, it's a book. How do we get DNA, and what came first, the DNA or the proteins? I'm reading from a science book that's not dealing with religion, not dealing with anything. He suggests the favorite way out of a conundrum is to switch attention to go between RNA. Once again, it's understood to be the weakest of answers, but since we have to prove that it has a by itself, so we're going to have to look at it. But so we have 2 things that are stupendous. So as far as beginning of life, there are 2 issues that are staggering. One is there is no simple life. There is nothing simpler than a cell, and the simplest cell is incredibly complex. It's a whole being. It has to be tiny, but it's a being that has in itself functions incredibly complex and has incredibly complex material to make it. Secondly, every living being is a combination of an instruction booklet and an actualization of that instruction booklet. How did the instruction booklet arise? Those are the first points that really, really severely shake the possibility of life coming from a lot of chemicals put together. Yes, Pinchas.
Maybe this might be too detailed a point, but was he saying that DNA is made out of protein, and yet DNA tells how to make protein?
Yes.
So
it's like it would be similar to a book telling you how to write a book.
Right.
But
where the original instructions.
But it's more than that. It's how did we can understand nature being collection of materials, but writing a code, writing a book is not just ink and paper. There is the minute if I put together chicken and eggs and potatoes, it's a conglomeration of materials. But DNA is not a material as such. It's a material that has writing on it and has an extraordinary complex instructions on how to produce living things, and in a way that makes the cell viable. Those 70,000 proteins are written in a language. It's a real language and a universal language written in this code how to produce it. How did that booklet get written? Material we can say conglomerated together and shook and was zapped and it became something fine. But the writing, I mean, you're talking about a real writing of the most complex chemistry book around, how to produce proteins. That's one point, and we'll hold it with that for this year.